Hello friends, welcome to our channel. Here we are going to look at problem 3508, implement router. Personally, I feel this is a very good problem. You could have some idea of how routing works in a simplified setting. So this is the one comment. Another one is that you could feel the power of using proper data structures. So here I'm not going to read through the problem statement, but I will just quickly look at the main point. First, a data packet consists three attributes: source, destination, and timestamp. The methods we are going to implement are the following. The first one is add packet, and the second one is forward packet, and the third one is get count. You can look at the requirement of these methods. So here are some consistency and size assumption. And also I want you to notice this one. Timestamp is in this range. And also the start time and end time, right? So this is number of calls. And this one is also very important. This greatly simplifies the problem because the queries for add packet will be made in increasing order of time. So we don't need to worry about, if later time we have some data packet which is with an old timestamp. So with that said, basically let's analyze what we should do, right? First, here this forward packet, right? So forward, the next packet will be first in, first out. So needless to say, you need to think of queue, right? So this is the data structure we need to include. Another one is that, so we want to get a count, right? Given the destination and then given the start time range, right? So we need to get the number of data packets in this range. So this way actually naturally comes to the sorted container, so the sorted set. So the sorted set will sort in, we can make it sort according to the timestamps. So this way, because this data structure, we can do binary search. So this will make this method very time efficient. This is the one. So the main idea actually is that we build a map like this. The key will be the destination, and the value will correspond to a sorted set. So each data packet will be something like this, right? A source, destination, and a time. So for each destination, so because there are many packets going to the same destination. So for destination, we're going to each destination, different destination, we're going to associate it with a sorted set. So this way, you can, for this destination, you can search the number of data packets in a certain time range, and also you can see different sources within this data range. So, but in this problem, we don't need to analyze the source. So this map actually is crucial for the implementation. This will decouple the destination with timestamp and source, right? Because a data packet is like this, a 3-tuple, right? It's 3-tuple. So we use this one as a key and the source and time as elements in the sorted set. So if you can grasp this point, then basically you could largely implement the router class. So the note in the problem statement is very important. So note that the query for add packet will be made in increasing order of timestamp. So this assumption makes us, we can just append the new coming data packet to the tail of the queue. And then when we do the forward, we just pop out the element in the queue top, right? So this is also emphasized in this constraint. So mostly we actually understand the constraints as additional assumptions about the consistency or about the problem size, right? So with that said, let's look at the implementation. First, we have a memory limit, right? So if it's out of the memory limit, which this will be the cap or the upper bound of number of data packets. So we can do self memory limit. Let me just write like this, memory limit. So this is the one. And also we need to have a queue So the queue will be, we can do collections deck. So the deck is a two-direction queue, but here I just use it as a queue. So another one is self-map. So I'm going to use default dictionary, default dict. So I'm going to map everything if it's not yet retrieved, everything to a sorted containers, sorted set. So actually in leetcode, you don't need this module name, so you can directly call this one and this one and this one. That will be okay. But here I write in a complete fashion so that you can do some practice outside leetcode, because this problem itself is not useful only for the solving a leetcode problem, but it can help you digest some concepts, right? So we finished the initializer, right? Let me make some annotation. So this will be destination, and the sorted set contains say t and the source. The reason we put t in front because this will be sorting according to this first. Once we have this, I also want to write a function to do some deletions, right? So if you pop something from the queue, you should also modify this map. So I just want to make it more modularized. So I'm going to write as a hyper. So self, we don't need to add additional arguments. So if not self queue, the queue is empty. So we're going to return an empty list. Otherwise, so we get a source and destination and temp. So it will be self queue pop left, right? I'm going to use this left as the queue head and right as the queue tail, right? So then what we do, we are going to modify the map, right? Self map destination. So because this is the essentially we want to remove the corresponding tuple t and the source, but we just can use discard method t and the source. So discard method is more error. This is more friendly, because if this element is not in the sorted dictionary, this just do nothing. If it were, I just discard. So because we are sure this is inside the sorted set, actually we can use remove method. But in general, discard method is encouraged. So once you have this, so you finish the update of this one. So you're going to return. So here, because if we do add forward, right? Let's see. You do forward, you are going to return something like this. So because we are going to call this method in forward, so I'm going to return this source, destination, and temp. So this will be the hyper method. So now let's do the add. So the add will be very simple. So here, one thing we need to notice that we need to first check if a packet is duplicate, right? If it duplicate, because we need to check this. So first we get if the timestamp and the source in self map the corresponding destination. Let me copy this so that we can avoid wrong typos. If this is the case, where we have a duplicate, we return false. So this is from the this requirement item 8, right? So now we should do the add. So we are going to self queue append. So we can append source, destination, and timestamp. So we can do this. It's largely due to this note, right? So now once you do this, you need to also update this map. So self map. So the destination. So we are going to add. So notice that here should be timestamp first, and then the source, right? So now we need to also check the capacity. So if length of this self queue. So I didn't use a running variable to count the size, because you retrieve the length of this queue is O1 operation, right? So if this guy is larger than self memory limit, so we need to do a delete, right? Essentially, we can do this hyperfunction, right? So what we do is self hyper. So this, because we do pop left, this is corresponding to pop out the oldest, or the earliest item or packet. So once we done this, so we should return true. This is the requirement for this add package. So now we done this one. So let's do the forward. So the forward, let's see the requirement. Remove the package from store and then return this one. So this will be rather straightforward, right? So what we do, if not self queue. So this is the forward. So I'm going to return nothing. Forward. This is the this item. So now what we do will be the following. So SDT will be self queue pop left, right? Then also we need to modify the map D, so we should discard. And so T and source. And then we should return S DT, right? The reason we got this unpacking this one is to do the map update, right? So this will be the forward. So now let's look at the get count. So this will be rather straightforward. If you notice the constraint, especially these two items here. So what we want to do is this. So we want to find, let's see. First, we want to find the sorted set corresponding to this destination. So self map. So destination. Because it's sorted according to the timestamp first, so we can do binary search. So so the first, so let me decouple it. So first is bisect right. So end time. So we should have a tuple end time, and then the source. The source will be like in 1 and this. So let's write a larger one. So 10 to the power 2 to the power 10 to the power 5. Let me plus 1, right? This is for sure largest. So this will give you the number of items before or equal this end time, right? So IDX2 will be this bisect left. So we have a start time. So here, because the time is at least 1, so I'm writing 0. So this will be strictly less than the start time, right? So because this one will be 0, right? So for sure less than 1. So what we want to return actually is IDX1 minus IDX2. So this will be the full implementation. Actually, you can see this each of the line actually corresponding to the bullet items in each function requirements. Let me first run it. Yeah, it passes the two cases. So now let's look at generic case. Yeah, it passes all the cases. So to give you a quick summary, so here actually we use data structures to do the implementation. The data structures involved is a queue and a sorted set, and we use a dictionary to connect this one, right? So this is the default dictionary, right? So actually this problem, as I mentioned at the very beginning, is very good, right? So if you do this problem or practice this, on one hand you solve the problem, on the other hand you could have an idea of how routing works in a simplified setting. With that said, I guess that's it for the current video. Thank you for watching.